Hello, my name is Dominic Messina. I am currently a senior chemical engineering student at Wayne State University. This is my team. We call ourselves the Space Cadets. We are the multicultural product of a global engineering program formed by Zhejiang University of Technology and Wayne State University. This program we're in is focused on innovation in the transportation sector, specifically on new trends and new technology regarding sustainability. With the rise of electric vehicles, the mass production of lithium-ion batteries will be scaling as well, and by some estimates, there will be well over 100 million electric vehicles on the road by 2030, which will equate to about 5 million tons of batteries being produced every year. Because of this, we have been led to our topic of research, which we've been working on for about a month now, and it is focused on lithium-ion battery recycling. So this is my team. Me, Dom, uh, my friend John Giannetti. He is a mechanical engineering student. I believe he's a sophomore right now. And then we have Edgar, Ari, and Leopold, our Chinese friends who we've been working with. Leo actually has a little bit of experience with electric bike batteries. He had opened his own business last year. He was kind of working uh, with what we call like a battery swap, where people would come with their old bike batteries and he would supply them with new ones. And he would take the old batteries and bring them to bike shops around here to be recycled. So, if you gain nothing else from this presentation, I want you to remember two main things. First of all, would be a little bit of lithium-ion battery recycling awareness, and second of all, will obviously be our business proposal. So first, big problem is that currently about 5% of lithium-ion batteries are being recycled, which is an extremely low number when you compare it to the lead-acid batteries, which are used to start your cars. Um, about 98 or 99% of those are recycled. So when you have a dead battery, obviously you go to AutoZone or wherever, bring in your old dead one, and they give you a discount on your new one. Well, this line of thought kind of led us to our business proposal, um, which will kind of help facilitate recycling by promoting battery collection. Obviously, metals are non-renewable, and we kind of compare this to the water cycle. So, in order for these metals to be used again, they must be extracted from spent batteries, brought back to the battery manufacturers, who obviously make new batteries, and then supply them back to the automakers. So for the first couple weeks of this project, we spent most of our time kind of just ideating the problem and figuring out like what can be solved. Um, we took a look at about 100 trends regarding lithium-ion battery recycling, um, and kind of analyzed what problems they're trying to solve and what problems still need to be solved. So this led us to our problem statement, which is there will be a need to eliminate dependence on mined lithium and mined cobalt before the supply becomes scarce in the mid-2020s. So in the bottom left corner, you can see that we have kind of a materials demand forecast up until 2030, obviously increasing exponentially over time. Um, so we found that the main problem isn't lithium, it's actually cobalt, which is used in battery cathodes. Uh, Cobalt sells for about $50,000 per ton, whereas lithium's more like 5 to 6,000. And actually, about 60% of cobalt is currently mined in the Congo, where some of it's actually mined by hand, like by children. So it's kind of an issue there. And regardless, we haven't seen the production increase very much over the past few years. So while the demand's steadily increasing. The production has kind of flatlined, and if it continues like this, we can expect that these materials will become scarce sooner rather than later. Another problem that we kind of identified was that lithium recovery itself is not economical, but most recycling processes focus on recovering what's called lithium cobalt oxide, which can be recovered and used again in cathodes. Um, Another problem is that uh, companies have already established what are called closed loop recycling relationships. Tesla is probably the best example of this, where they have a contract with a recycling facility to um, take their used batteries, recycle them, and then take the valuable materials and give them to the battery manufacturer, obviously, which would supply the battery back to the car manufacturer. Um, and then lastly, there's no real legislation which standardize battery shape or size, which makes recycling even harder and more costlier than it already is. So how did we get to where we are today? Well, at the beginning of the semester, we were broken up into groups kind of based on our interests. We were allowed to choose two of three technical tracks, the first one being alternative energy and the second one being intelligent vehicle systems. And for the past few weeks, we've been collaborating on what is called Trello. It's a website which kind of allows you to make lists and kind of organize stuff. Um, as I said before, we observed about 100 trends and we categorized them based on Jeff DeGraff's innovation genome. He's a professor at U of M, if you want to look any more into him. And as I said before, we kind of looked at what problems we had at hand and kind of explored solutions based on these trends. So these are just a few examples of the many, many trends that we found. We actually gave a presentation to Volvo, whose company will be going all electric by 2019. They will be producing purely electric vehicles and hybrids. Obviously Tesla with their electric vehicles, autonomous driving, all the fancy stuff. And as I showed before, kind of an exponential curve or exponential demand for lithium ion batteries. So as we were exploring solutions, we kind of wanted to figure out what we want our future to look like. There's kind of a famous quote among engineers that goes something like, if you want to predict the future, just go out and make it yourself. So what we want to see is at least 95% or more of lithium ion batteries being recycled, kind of how, like about this percentage of what the lead acid batteries are being recycled at right now. We think the we think the reason for the low percentage right now is because that there's no incentives and it's honestly much easier to just throw your phone battery right in the trash. So we want to see some sort of incentive for recycling your batteries. Next, we want to see battery manufacturers using at least 50% recycled materials. We also want to see standardized battery sizing for electric bikes and EVs, which would kind of help the recycling process. And lastly, we want to see new or better cathode chemistries to kind of get rid of this dependence on cobalt. So here is our business model. Kind of, but not really. This was like our first mock-up of it, where it's kind of just scribbles. Okay, but here is our actual business model. So our platform is on electric bike battery delivery and lithium-ion battery collection. Um, we're hoping this would facilitate battery collection through convenience and incentive. Um, Delivery is extremely popular here. They do it through an app known as WeChat. Um, so the delivery people ride their electric bikes. I've been talking quite a bit about electric bikes. It's because there's like 300 million or more here. I can't remember the exact number, but they are absolutely everywhere. And basically, these delivery people, it's kind of like a third party thing, similar to Uber Eats, if you know what that is. But basically, they will go to the restaurant, pick up the order, and deliver it to the customer. And it is like extremely cheap. It's like $3 for a full meal delivered here. Um, so we're hoping to kind of do the same thing, but instead of getting food, the delivery person would get a new battery, deliver it to the customer, swap it out, and take the old battery. And the incentive for that is if the customer gives us the old battery, um, the delivery fee would be nullified. So then we would take it to our kind of a storage facility. It would be probably like a dorm or like a rented room right now, but um, you need at least a ton of batteries to bring them to be recycled. So we would store them until we have enough to call a truck and then load them up and have them hauled to the recycling facility, who pays anywhere from 30,000 to 35,000 yuan, which translates to um, like $5,000 to $6,000. So that's our model. Kind of our short-term goals would be actually owning the delivery trucks to bring the batteries to the recycling facility. Um, and then we would like to kind of keep a database of like what batteries are being ordered, so that eventually we could figure out like what batteries to get for a new battery inventory, kind of cutting out the bike shops and starting to profit off of the delivery segment, and then keep a database on like delivery times and distances, so we can optimize a location for our storage facility. Um, Probably have at some point maybe have more than one in Hangzhou, where we stay, and then obviously try to scale it up, move to bigger cities such as Shanghai, Beijing, Guangzhou, kind of the bigger cities in China. And then one of the biggest problems with battery recycling right now is that these lead acid batteries and lithium ion batteries are being recycled like in the same recycling facility, which has been causing like fires and some major issues, like other than just not being able to get the right materials out of it. And then lastly, we would eventually like to move into the EV battery market in the United States and Europe, since electric vehicles are obviously more popular there than electric bikes. So that was my presentation. Kind of going back through the recordings a little bit, I feel like I might have missed a couple minor points. So if you have any questions for me, just feel free to contact me. Um, I'd also like to take a minute to thank you for your consideration and working with Dr. Tan to kind of figure things out for me. Obviously, trying to enjoy China as much as I can, like regardless of all the issues I've had, but I really do appreciate it, and I'd like to thank you for your time.